So this class we'll be looking at the cosine rule. We have finished our sine rule. Then the cosine rule is what we are going to apply in solving our triangles, in looking for the side or any of the angles unknown. So like we established in the concept of sine rule, we said the sine rule is used for only triangles with matching pair of opposite sides. So the cosine rule also can also be used for matching pairs of opposite sides. So it's also applicable to opposite matching pairs. So we have this, we have A matching to angle A, and B also matching to angle B, and our C also matching to angle C. So these are opposite matching pairs. And it's also applicable if you have three side giving. You have side, side, and side giving, or you have two sides of the triangle giving and one angle giving. It can be this angle, it can be this angle. So this is when you apply your cosine rule. Please take note, it is not applicable for any triangle that has to do with 90 degrees. So we don't apply our cosine rule to 90 degrees angle. So it's only applicable to this when you are given three sides of a triangle or two sides and one angle given. So how do we apply this? So we have for our A, which is this. So looking for A, we have A squared is equals to B squared plus C squared minus 2 of B times C cos A, which is the angle at A. Then what if you are looking for side of B? We'll just switch places here. The B replaces your A, so I will have B squared is equals A squared plus C squared minus 2. In the place of B, A will be replaced there. So we have 2AC cos, since we are looking for B squared, it becomes cos B. Same thing with our C. Looking for C squared, C squared is going to replace this also. So I have C squared is equals A squared plus B squared minus 2AB cos C. This is for your cosine rule. So you have to have this in mind. That this is what you apply when you're looking for the side, either B, C, or A of your triangle. So which is also different when you're looking for any of the angles given, we can apply this formula to it. So we can have our cos C will be A squared plus B squared minus C squared divided by 2AB. Or you can have cos A also as B squared plus C squared minus A squared divided by 2BC. Or you can have cos B as your cos B can be A squared plus C squared minus B squared divided by 2AC. This is when you are looking for any of the angles given either three sides of the triangle. So we are going to be applying our cosine rule in finding the missing side of this given triangle. So applying the cosine rule, if you look at this triangle, we have our side matching opposite side, you see, as 90°. So I have A matching opposite side to A as X, Then I have my matching opposite side to be as 12 centimeters. So then we are looking for x, which is A. So I have A equals 20 degrees. That is my cos A. I'll write it as cos A. Then I have A as x. I have my side of B, the matching opposite to B here, as 12 centimeters. So you write your B as 12 cm. Then you have the matching opposite side to C as 9 centimeters. So C becomes 9 cm. So what are we looking for? We are looking for A squared. We are looking for, so applying our cosine rule that says A squared equals B squared plus C squared minus 2BC cos A. So we have A squared, which is x given to us there. So A squared will be what? Our B is 12. So I have 12 squared plus our C is 9, which is 9 squared, minus 2. Our B is 12 and our C is 9. Cos our A angle is at 20 degrees. So what do we have? So we have A squared. 12 squared is 144 and 9 squared is 81. So you have 2 times 12 times 9. 2 multiply 12 multiply 9 gives us 216 cos 20. So we have 216 cos 20. So on your calculator, you can do 216 cos 20 degrees, which gives us 202.97. So adding 144 to 81, we have 225. So you can have 225 minus 202.97. That gives us 22.03. So I have my A squared as 22.03. Take note that we are looking for A and not A squared. So, like I said previously in my other class, so A becomes the square root of 22.03. So looking for the square root of 22.03, we have our A as 4.69. So A is given to me as 4.69, or you can approximate it to 4.7 cm. So the value of A in this is 4.7 cm. So that is the application of your cosine rule. So we are moving further to using our cosine rule to find any angle. So for example, in this triangle, we have side 10 centimeters, we have side 14 centimeters, then we have side 12 cm. Then we are looking for an unknown angle marked here. Always take note, your sine and cosine rule has to do with matching opposite sides. So the matching opposite side of your angle theta here is 10 cm. So it is easier for you to apply your cosine rule in finding this. So I have my theta, our angle is theta, which we don't know, we are looking for that, which is opposite to 10 cm. So I can say this is our B is theta and our side of B is 10 cm. Then we have the other two sides given to us as 12 cm and we also have 14 cm. So it's either you refer back to this formula I gave to you before. I gave it, if you are looking for your angle, you use this formula. Or you can go back using the one you already know and substitute. So using if you're using your b squared, your b squared is equals to a squared plus c squared minus 2ac cos b. Or you're using cos b, which is what? A squared, we are referring back to this, plus c squared minus b squared divided by 2ac. Any of this formula will work out perfectly. So what is our cos b? That is what we are looking for. We don't have cos b. So our cos b is cos theta equals, what is our a given to us? We can take any of this as a. So I have a as 12 squared plus c as 14 squared minus my b squared given to me. If you look at the triangle is 10. So I have minus 10 squared divided by 2 multiply 12 multiply 14. So on your calculator, you do 12 square, which will give us 144, and 14 square is 196, minus our 10 square, which is 100, divided by 2 times 12 times 14 gives us 336. So adding 144 plus 196, then minus 100 gives us 240. So we have 240 divided by 336. So 240 divided by 336 gives us 0.714. So we have our cos theta as 0.714. So I'm looking for theta, so theta becomes cos inverse of 0.714. Like I said earlier, press on your calculator your shift function and cos 0.714, which gives us 44.43. So our theta for this angle is 44.44 approximately, or 4. So any of these will do. So we've gotten the angle for this as 44.44. But if you take a look at this is a bigger angle, which is, we can use our cosine formula. Proceed with solving extended questions using trigonometric rules. So we are taking this example using this triangle. A crane arm AB of length 80 meters is anchored at point B at an angle of 40 degrees to the horizontal. A wrecking ball is suspended on a cable of length 60 meters from A. Find the angle X to which the wrecking ball rotates as it passes the 2 point level with the base of the crane arm at B. So we are going to be looking for the angle marked X from here. We have extracted this triangle to this point. So watch out, we are at the matching opposite side of this. For our angle B, we have at 60 meters. And for this angle here, we have at 80 meters. So which of the rules are we going to apply? Since we have B at this, and we are looking for our angle marked at X, that means we can find this angle here. In order to be able to find this, then we can proceed with solving of our X angle. To any of them, or you can look for this opposite of this. So any of these will serve. So let's proceed with this. I'll have to divide this triangle into two using this first, then I can proceed with the larger triangle. On that, I have my side A, my side B given to me. as 60 meters, which is angled at 40 degrees. Then I have this angle here, which is what? Theta at 80 meters. So I'm going to look for theta. Which of the rules can we apply here? We apply the sine rule, which we have as b divided by sine b equals c divided by sine c, or a divided by sine a. So I'll have 60 divided by sine 40 equals 80 divided by sine theta. So I'll have to cross multiply. So I have 60 sine theta equals what? 80 sine 40 degrees. So we divide by 60 in order to find sine theta. So we have 80 sine 40 is 51.42. So we have sine theta at 51.42 divided by 60. So we have sine theta as 0.857. So what becomes my theta? So we have theta as sine inverse of 0.857. So your sine inverse of 0.857 is 58.98. Which can be approximated to 59 degrees. So we have theta here at 59 degrees. Like I said earlier, your sine rule can give us two possible values of theta. Two possible values. And how do we get the two possible values of theta? How do we get the two possible values? So we say sine theta is 180 minus theta given. We found the theta as 59 degrees. So we have 180. The other value for theta is 180 minus 59 degrees. So 180 minus 59 gives us 121. So since it's an obtuse angle, the value for this becomes 121 degrees. So take a look at this triangle. This is an isosceles triangle. That means this angle, this side is equal to the side. That means they have same base angle. So like the previous questions I saw, I have my theta as 59. So here is going to be 59. And that means here is 59 degrees. So we have a triangle here, and the sum of angle in the triangle is 180 degrees. So how do I have x? So I have x plus 59 gives 180 degrees. So that means x plus 59 plus 59, that's 118 is 180 degrees. So x will be 180 degrees minus 118 degrees. So what we have? We have x as 62 degrees. So we've gotten our x value here as 62 degrees. So that is for our first question. So the B part of the question said we should write down one modeling assumption you have made. So the assumption we can make here is that the ball swings symmetrically. So that is the modeling assumption we can make from this question. We are looking at other applications using our cosine rule and the sine rule in solving our triangle. So we look at this triangle given to us here. You can see that these triangles are two different triangles joined together. We have triangle A, B, C here. And we also have triangle A, B, C. It is all joined together to form B, A, C. So this is the triangle, this is the shape we have here. So we are going to be applying sine rule and cosine rule to this. So I'm going to divide this triangle into two. I'll take this as the first part. Then you can use to solve for either the entire triangle or you solve for this triangle. So in the first triangle, what do we have? We have side, side, side. I told you if you have three sides given to us, we apply our cosine rule. So in using this three sides, what angle can we find, or what angle should we find to help you to resolve your x centimeters? So if you decide to find this angle, or this angle, or this angle. So if I'm going to look for my A angle, I'm going to have c squared plus 10 squared minus 2 times 6 times 10 cos A. But if I'm looking for my D angle, so I'm going to have D squared, where's the matching opposite to D, which is where? This. So my D squared equals what? A squared plus C squared minus 2AC cos B. Since we are looking for the angle and not the side of D, we go back to the formula I applied earlier. I said we use cos D equals what? A squared plus C squared minus D squared divided by 2 times A times C. So we have A as 7 cm. We have D as 10 cm. Then we have our C, which is the matching opposite to C here, as 6 cm. So we move forward using our formula above. So we have cos D equals 7 squared plus 6 squared minus 10 squared. Divide 2 multiply 7 multiply 6. So on your calculator, 7 squared gives us 49 plus 36 minus 100. Divide 12 times 7, that's 2 times 7 times 6. What do we have? 2 multiply 7 multiply 6 gives us 84. So add the values of 49 plus 36, subtract 100, gives us minus 15 divided by 84. So I have my minus 15 divided by 84 gives minus 0.1786. So I have cos D as minus 0.1786. So we were looking for D. So how do we get our D? So D becomes cos inverse of 0 minus 0.1786. So on your calculator, you go to your sheets and cos negative 0.1786, which gives us the cos inverse of 0.1786 gives us 100.3. So we'll go back to the triangle here. We have this part, this angle at B at 100.3, where this tan is done as 180 minus 100.3. Okay, so we have 79.7. So this angle here is 79.7, and the angle marked here is 100.3. So going back, we are looking for x value. So we can still apply our sine to find x, because this is the matching opposite to your x. And we can use our b to the matching opposite of b. So what do I have there? I have x over sine of x is equals to b over sine of b. So we are looking for x, so that will be x over, we already have the angle at that as 100.3, which will give us our b, which is 7 cm, okay, and 60 degrees. So we have 7 divided by sine 60 degrees. So we cross multiply. We have 7 sine 100.3 equals x sine 60. We divide both by sine 60, sine 60. So 7 sine 100.3. We have 6.9999 thereabout divided by sine 60 is we have 7.95. So that is the value for x. So our x centimeters is 7.95 cm. We can have other alternative method in solving this triangle. It also might be an easier way for you. If I could use this angle here and solve it after you've gotten the angle at this. So I can use my A here to find the angle at A. So using the same, we have A as 7 centimeters. Any formula, any way, any method, any of the side is there to use will still give me a C. So we have our angle at A at theta. Then we have C at 6 centimeters. And we have our D at 10 cm. So in looking for A, same formula, we have cos A is equals C squared plus D squared minus 2 minus our A squared divided by 2 multiply C multiply D. So we have cos A as 6 squared plus 10 squared minus 7 squared divided by 2 times 6 times 10. So what do we have there? So our cos A will give us 36 plus 100 minus 49 over 120. So what cos A, we add 36 plus 100, that is 136 minus 49 divided by 120. So cos A is 0.725. So we are looking for A and not cos A. So A is cos inverse of 0.725. So we have shift cos of 0.725 gives A as 43.53 or 5 degrees. So we've gotten A as 43.5 degrees. We can apply it now using the bigger triangle, which is A opposite this and 10 opposite 60. We have A as 43.5 degrees. And A as XCM. We have B as 60 degrees and B as 10 CM. So we can apply our sine rule here as A divided by sine A equals B divided by sine of B. So we have X divided by sine 43.5 equals 10 divided by sine 16. So we cross multiply. We have X sine 60 equals 10 sine 43.5. Divide both sides by sine 60 since we are looking for X. Divide by sine 60. So my X value will be 10 sine 43.5 divided by sine 60, giving us 7.95 centimeters. So you can go back to the previous one I used to. We have same answer as 79.5 centimeters for our answer. So you can see it here. So any of the method you use, any of the side you use should give you the same answer. Thank you. Looking at this shape given to us, this is the shape in the form of a quadrilateral. Okay, a farmer has a field in the shape of a quadrilateral as shown. The angles between, for instance, AB and AD is 74. This is, for instance, AB and AD. So we are told that the angle between them is 74 degrees. We are looking for the angle between faces BC, this is BC, and CB. So we are looking for this angle. So this is the angle we are asked to look for. Before we proceed, I will want to divide this shape into two parts. So I'll draw a line to separate this quadrilateral as shown. So for that, you can see I have this triangle A, B, D. So I have triangle A, B, and this. Okay, so I'll be using that triangle to find the value of the side. I'll use the triangle to find the value of the side. So what are we going to apply? We have two sides and an angle. So what comes into mind, since we are looking for one of the unknown sides? I say if you have two sides, one angle given, it's easier for us to apply the cosine formula. So we have the cosine rule coming into play here, where A is 74 degrees and AD is 120. I'll mark that as B because it's the opposite side to B. Okay, B. So I have that as 120. Then I have this here, which I will take as my B as 75 meters. So how we are going to look for this part, I will label my X. We're using the formula we have, X squared equals 120 squared plus 75 squared minus 2 multiply 120 multiply 75 cos 74. So X squared will give us, if you have your 120 squared plus 75 squared, will give us 2,025 minus this cos this will give us 4,961.5. So I have X squared as 15063. Mind you, we are looking for X and not X squared. So X is equals square root of 15063. So my value for X is 122.73 meters. So I've gotten the value for this. So now, since we've gotten the value, we can use the value we have for this to solve for the second triangle, giving X as 122.73 meters. So we look for the value of theta. The theta here matches to the X value we just got. So which of the methods can we use? You can apply the sine rule here. You can apply the cosine rule. Since we already have two sides, we have two sides, we have this, or we also have this, which is three sides given, and we are looking for an angle. So I'll choose to go with the cosine formula, which will be easier for us in order to find C. So I told you earlier, if you're using the cosine formula to find any angle, so we are looking for cos C, will be what? A squared, or we have it as B squared there. Since I already used B squared, I'll refer back to my B squared, or any of them can go, plus A squared minus 2 multiply so that will be minus C squared divided by, sorry for that, that was said, divided by 2 times B times A. So I'll have cos C equals, what do we have? We have 60 squared plus 135 squared minus our X value, which is 122.73 squared. So we have divided by 2 multiply 60 multiply 135. So for C, we give us 60 square plus 135 square minus 122 will give us 6769.71 divided by 16200. So we have our cos C as 0.4179. Since we are looking for C and not cos C, so it becomes C equals to cos inverse of 0.4179. So C equals 65.3 degrees. So we've gotten the angle at BC and CD. So that's the angle at BC and CD as 65.3 degrees.